To our sun-fueled eyes, this bright horizon represents the definitive blueprint of life on Earth. But 70% of our planet belongs to a world that sunlight has never known. We are descending into the midnight zone, a vast kingdom defined by crushing gravity and absolute darkness. At this terrifying depth, gravity is an architect, forcing life to build weird and alien solutions. This is the very edge of the biological rulebook, where pressure is over 8 tons per inch. And it is here, around these hellish chimneys, that the rules of existence were rewritten. Now, look closely. The water has frozen over. We are no longer on Earth. We have traveled 600 million miles. Welcome to the subsurface ocean of the moon, Europa. To understand what might live in the cosmos, we must first reverse the geological clock. Geography is destiny. The Earth is a shifting jigsaw puzzle, and geography determines the environment. Here, a cataclysmic collision created a fracture so deep it could contain Mount Everest. This environment is defined by its negatives: no light, no warmth, and nearly no nutrients. But the geology of Earth provides a chemical oasis. This is a black smoker, a chimney of sulfur. The water here is toxic to most life, reaching temperatures of 700 degrees Fahrenheit. But where we see a poison hell, chemistry sees a new source of fuel. The geology of Europa presents a very different face, a shell of ice 15 miles thick. The surface is a chaotic graveyard of ice, but geology hides its secrets below. Beneath this armored crust lies an ocean of liquid water, deeper than any on Earth. But why is the water liquid? The architect here is not the sun, but Jupiter itself. Tidal flexing. Jupiter's immense gravity kneads the moon like dough, generating heat in its rocky interior. This internal heat must escape. We believe Europa's dark ocean floor is scattered with hydrothermal vents. Two worlds, separated by millions of miles, share the exact same chemical forge. If the geology is similar, the foundation for life must also be similar. We call it chemosynthesis, the revolutionary act of creating food without a single photon of light. The geologic stage is set: darkness, pressure, chemistry. The ingredients for the first Europan, down here. Earth's biology doesn't just survive the toxic abyss, it actively feeds on it. These are giant tube worms. They have no mouth, no stomach, and no digestive tract. Instead, they host billions of symbiotic bacteria that eat the vent's toxic volcanic exhaust. This is chemosynthesis in action, a thriving alien garden fueled entirely by the underworld. The Yeti crab farms its own food, using its hairy claws to harvest volcanic bacteria. In this crushing darkness, evolution favors the bizarre, the efficient, and the utterly blind scavengers. Move slightly away from the volcanic heat, and the abyss becomes a haunted hunting ground. Bioluminescence is the language of the deep, a glowing trap set in absolute nothingness. Where sunlight fails, biology creates its own stars to lure the unwary directly in. If Earth's abyss bred such monsters, what swims in the dark, frozen oceans of Europa? Under the Jovian ice, alien biology would also be anchored to the volcanic chemical heat. Vast carpets of crystalline bacterial colonies might drape across the Europan rock, harvesting Jupiter's friction. Without light, Europan grazers would be blind, relying entirely on touch and chemical sensors. Their translucent bodies would hide no secrets, offering no pigmentation in a world without sun. But where there is grazing life, an apex predator inevitably evolves to aggressively consume it. In Europa's boundless dark, a predator might use rhythmic light displays to stun its prey. Lacking eyes, it detects the subtle electromagnetic fields generated by the terrified movements of others. A biological arms race played out entirely in the pitch black, millions of miles away. The entire subsurface ocean could be a swirling, glowing galaxy of bioluminescent alien ecosystems. But this ecosystem is trapped, sealed forever beneath a 15-mile thick vault of impenetrable ice. Some European extremophiles might not live on the floor, but graze upside down on the ice ceiling. An upside-down reef, sustained by chemicals slowly freezing out of the ocean over geologic time. Earth's deep ocean proves that life doesn't just endure the extremes, it aggressively flourishes. For billions of years, these deep-sea earthlings lived in perfect, undisturbed, sunless isolation. Convergent evolution dictates that the same environmental pressures will carve out remarkably similar biological shapes. To swim in the abyss is to surrender to the brutal physics of water and pressure. The cycle of life and death down here is absolute, unforgiving, and entirely self-contained. But what happens when the geology itself becomes violently unstable in these alien depths? On Earth, tectonic plates shift, violently altering the landscape and destroying deep-sea vent communities. When a vent dies, the ecosystem it supports plunges into immediate, inescapable starvation and freezing death. Without the chemical fire, the darkness reclaims its territory, erasing centuries of relentless biological struggle. On Europa, the danger comes from above. Jupiter's gravity constantly and violently flexes the moon's shell. The ice tears open. Pressurized ocean water erupts violently upward, seeking the freezing vacuum of space. Whole ecosystems could be violently swept away, instantly flash frozen as they are blasted into the cosmos. These monumental geysers blast European ocean water, and perhaps frozen life, straight into the silent void. Suspended in ice, this alien biology is suddenly exposed to the deadly, unyielding radiation of space. This violent cosmic venting isn't unique to Europa. We see the exact same geysers on Enceladus. Humanity has already flown through these cosmic plumes, literally tasting the water of an alien ocean. Inside that frozen spray, our probes detected complex, carbon-based organic molecules, the very building blocks. Even as old ecosystems are destroyed, new chemical fires ignite across the dark alien seafloor. Alien spores, drifting in the dark abyss, sense the new heat and descend to colonize anew. The biological struggle is relentless. Life, even in a freezing, crushing hell, is aggressively stubborn. For 4 billion years, Earth's dark oceans have operated on these exact, unforgiving geological rules. It forces us to ask a profound, unsettling question about the very origins of our own existence. Did life on Earth truly begin in a warm, comfortable, sunlit tidal pool on the surface? Or was our genesis sparked in the violent, crushing, pitch-black inferno of the deep abyss? Many scientists now believe the terrifying deep sea, not the sunlit surface, is our true cradle. And if life began in the absolute dark of Earth, the implications for the cosmos are staggering. It means that a warm, comforting sun is not a prerequisite for biology to take hold. The universe is teeming with dark, icy worlds, hiding warm, chemical oceans deep within them. For generations, we have looked up to the heavens, seeking the warmth of a yellow star. But the deep sea taught us that biology is far more resourceful than we ever imagined. Imagine the moment a robotic submarine finally melts through Europa's 15-mile thick armor of solid ice. The probe descends into a pitch-black alien ocean that has been sealed away for billions of years. Its artificial floodlights cut through the virgin darkness, revealing towering chimneys of smoking, black volcanic rock. And there, clinging to the volcanic heat, are sprawling mats of alien, bioluminescent, chemosynthetic organisms. This is not Earth life transplanted. This is an entirely separate, independent origin of complex biology, a second genesis. Absolute proof that the universe naturally organizes chaotic chemistry into living, breathing ecosystems. The implications of this single conceptual discovery would instantly shatter our Earth-centric view of existence forever. We would no longer be a miraculous, isolated accident, basking in the rare light of a perfect sun. Life would be revealed as an inevitable consequence of wet rock, crushing gravity, and internal planetary heat. There are billions of stars in our galaxy, but there are trillions of rogue, icy, wandering moons. If life can aggressively thrive in the abyssal dark of our own solar system, it is everywhere. The cosmos is likely teeming with hidden oceans, entirely disconnected from the light of any parent star. Think of the countless wandering planets, ejected from their solar systems, drifting in the frozen interstellar void. Even in the absolute zero of deep space, tidal friction from a heavy core could keep them warm. Beneath miles of frozen crust, massive hydrothermal vents could pulse with vibrant, bizarre, and terrifying alien ecosystems. Entire civilizations of blind, aquatic creatures could evolve, live, and die without ever seeing a single sun. They would have no concept of day or night, no shifting seasons, and no starry sky above them. And their entire universe would be strictly defined by the rocky floor below and the impenetrable ice roof above. The violent heat of the vent is their sun. The toxic sulfur is their daily bread. And just like the tube worms of the Mariana Trench, they would be perfectly adapted to their hellish paradise. This is the ultimate triumph of geological determinism. The brutal environment completely dictates the shape of survival. Liquid water and kinetic heat are the universal solvents, forcing dead chemistry to awaken, mutate, and adapt. The discovery of a single crawling extremophile on Europa would rewrite the history of the universe forever. It would mean the resilient tree of life has countless, disconnected roots spread across the vast cosmic dark. We are not the pinnacle of creation. We are merely the sunlit branch of a much darker forest. The universe is not a sterile void waiting for a miracle. It is an aggressive, unstoppable biological engine. Every cracked, icy moon, every heavy water world is a potential cradle for the extraordinary. We have spent centuries screaming into the sky, waiting for a metallic voice to answer from the stars. But the very first alien contact might not be a radio signal from a distant, sunlit civilization. It might simply be a glowing, translucent crab, blindly harvesting sulfur in the absolute, crushing, oceanic dark. In 1960, humanity first plunged into the Mariana Trench inside a tiny, cramped steel sphere. We expected to find a barren, crushed wasteland, a dead zone completely devoid of complex biology. Instead, peering through the thick acrylic, the explorers saw a flatfish swimming in the freezing mud. That single observation shattered biological dogma. It paved the way for modern, high-tech, deep-sea robotic exploration. We discovered that life does not merely survive the abyss. It aggressively colonizes the crushing dark. The engineers who built our deep-sea submersibles are the intellectual ancestors of today's astrobiology pioneers. Today, humanity is assembling massive, radiation-hardened spacecraft designed to hunt for these exact alien chemical oases. We are hurling our robotic avatars across the solar system, chasing the legacy of the Mariana Trench. The journey is incredibly long and cold, a relentless voyage of hundreds of millions of miles. Our target is the Jovian system, a chaotic realm ruled by immense gravity and deadly radiation. Our probes will meticulously map the fractures, searching for thin ice and the chemical signatures below. We will taste the erupting geysers, hunting for the complex carbon molecules that whisper of biology. Eventually, we will land. We will deploy thermal drills to melt through the miles of frozen armor. It will be the most daring descent since we first plunged into our own Pacific abyss. When that machine finally breaches the hidden ocean, it will carry the hopes of an entire species. We are no longer looking for little green men in flying saucers. The search has matured. We are looking for the blind, the bioluminescent, and the extreme, the survivors of the cosmic dark. We are looking for the biological echo of our own planet's most hostile and unforgiving environments. For if life can spontaneously ignite in the sealed, pressurized pressure cooker of a distant icy moon, then the universe is not a barren desert. It is an infinitely fertile, sprawling biological archipelago. Every star system with a gas giant and icy moons becomes a potential cradle for the extraordinary. Even the cold, starless voids between the galaxies might hide trillions of isolated, heat-driven aquatic worlds. The sheer scale of this biological potential forces us to confront our own fragile place in the cosmos. We return to our sunlit surface, where the warmth of our star makes life seem so effortless. But we now know the truth. The sun is a luxury, not an absolute biological requirement. The true engine of life is planetary friction, kinetic heat, and the unrelenting force of geological change. Earth's deep ocean is a mirror, reflecting the hidden, violent mechanics of a much larger, darker universe. It is a testament to the aggressive, unstoppable, and wildly creative force of deep-sea organic chemistry. As we prepare to finally pierce the ice of alien moons, we carry the lessons of the abyss. We know exactly what to look for, because we have already seen it in our own depths. The alien is not out there, waiting in the stars. The alien has been here all along. So when we finally look into the dark oceans of another world, will we find strangers? Or will we simply recognize the deepest, oldest reflections of ourselves?